It seems you can't go a day without hearing the economy's doing amazing, but that doesn't always translate to what your account looks like after buying snacks, games, movies, clothes. For a lot of people, those are luxury items not even worth thinking about. Rent and food come first. How about this? Let's take a little over an hour to learn a new programming language and develop a tool to keep track of your finances. Hello and welcome back to my channel, Tech Construct. Today, we'll be learning the basics of Kotlin in order to create a simple budget app. To start, let's get an idea of what Kotlin is. Kotlin is what's known as a statically typed programming language. When a language is known as being statically typed, all that means is that the variable types are known at compile time. On your screen, you'll notice that we have a number of different variables. We have the variable name, followed by the variable's type. For a statically typed language, the compiler must be able to infer what that type is. If you're familiar with Java, then a lot of what you'll see in Kotlin will click a lot easier for you. The reason being is because Kotlin is designed to interoperate fully with Java. We're going to need to go over the building blocks. And what better place to start than variables? In Kotlin, we have a couple of ways of declaring our variables. You have val and you have var. The difference between these two methods is val creates what is known as an immutable variable, whereas var creates a mutable variable. You would use val when you want to create a variable that is meant to be read-only, as immutable simply means that value can't be changed. As you can see on the screen now, on line 3, I'm assigning a new value to immutable value, or I'm trying to. Your IDE will throw an error, and that error will be val cannot be reassigned. If you want your variables to be able to be reassigned, then what you're going to use is the var keyword to create mutable variables. As you can see on line 4, I have mutable var int equals 4096. To summarize the declaration of a variable, our syntax for declaring our variables are thus the usage of the keyword val or var, followed by the name that we're going to give to that variable, colon, our type, equals whatever that value is supposed to be. Now, remember earlier when I mentioned for statically typed languages, the compiler needs to know what types that you're using for your variables, and that those types can be inferred. If we come down to lines 7 and 9, you'll see that I have val, followed by our variable name, equals some value. On line 9, I have var, our variable name, an int, equals an integer value. The reason being is because in Kotlin, double quotes denotes a string. When it comes to numbers, in particular integer types, when you initialize a variable without an explicit type classification, our compiler auto-infers the type of being the smallest range starting from ints. To put simply, if you're creating a number, which we'll go over shortly, the type int is automatically assigned to that number unless you're giving a number that is going to be outside the range of int, in which case a long would be used otherwise. Next, let's go over the different data types that you'll find in Kotlin. In Kotlin, everything is considered an object. On any given variable, you can call member functions and properties on said variable. What that means is, on line 23, let's take our variable num transactions. What we have here on line 25 is num transactions dot toLong. This is a common way of converting one data type to another. In this particular case, on line 25, we are taking our integer and converting it to a long via the built-in function that is supplied by the integer class. Just keep that in mind as we go along, as we're going to visit classes down the line. For now, it is important to know that there are different types of data types. The first type that we'll go over are number types. Number types can be broken into two different types, that being integers and floating point. For integers, we have four different types. We have what's known as a byte, a short, an integer, or int, and a long. Each of the four have their own specific range. And how I have them listed here, they go from order of least to greatest, meaning a byte has the shortest range of -128 to a maximum value of 127, and a long has a ridiculously high number, the smallest number being -2 to the 63rd power, all the way up to 2 to the 63rd power minus 1. To reiterate a previous point that has been made, when we're talking about integers, when you're initializing a variable without explicitly giving a type classification, the compiler will auto-infer the type from the smallest range starting from int. That makes a bit more sense now that we know what those ranges are, meaning when you just give a plain number, when you're doing a declaration for an integer, when you just give a plain number and don't explicitly give a type, integer is going to be the smallest number. It's going to be the smallest data type that is inferred, unless you do something like this. On line 24, you see that we have the variable bank ID number :long equals this large number followed by the suffix L. However, for the sake of our example, for right now, I'm going to comment out line 24. On line 25, you see that we have the same variable, var bank ID number equals a different number. What is so significant about this number is that this number here, 2,147,483,647, is actually the max number that can be given to an integer. On line 26, I am printing out the class that is used for bank ID number. As we see over here, our print statement is going to print out class Kotlin.int. However, if I change it back and replace that 4 in the 10 space with a 5, well, now you see on line 26 over in our output, class Kotlin.long. That is because, given this number here, which is outside of the range of int, we're going to infer a long value. We don't even need to use the suffix L because the value long is implied without explicitly stating L. That's not to say that you can't have a number like, say, 247 as a long. You just need to use the suffix L to denote that you're creating a long. Let's clear these out. Let's talk about our next numbers. Our next type, which would be the floating point types. Floating points have just two types. The first is float, and our second is double. Similar to our integer types, where we have a default that we infer, in the case of floating points, double is inferred when no type is specified. To explicitly specify a float type, we simply add the suffix f to whatever number that we're using. You may be asking yourself the question, well, what is the difference between a float and a double when they both seem to be the same thing? Minus a particular suffix f. Well, Float is used to reflect what is known as the IEEE 754 single precision, while double reflects double precision. All that simply means is single precision, 32 bits are used to represent a floating point number, as opposed to double, as the name implies, 64 bits are used to represent the floating point number. Now, when we're talking about numbers, it's important to note that, unlike other languages, the concept of implicit widening does not exist in Kotlin. What this means is that if you're expected to use a double, then a double must be passed in, whether that is you passing in an argument to a function, or if you're assigning it to a variable. In other languages, it's perfectly fine to do something like this. On line 30, I created a variable called testNum of type int, and I'm trying to assign it the value 4820.0. In other languages like Python, Java, C++, this assignment would work because the only thing that language would do is just drop the 0 and assign the value 4820 to our testNum. Some languages may try to round this in the event of something like, say, 0.7, whereas I believe most languages just cut this bit off. However, Kotlin does not do this. As you saw on the screen, this results in an error. In your IDE, it'll more than likely tell you what that error is, which in IntelliJ is the floating point literal does not conform to the expected type int. That is a long way of just saying you can't assign a float to an int in Kotlin. Now, let's just say you are dead set on doing this. Remember when I said that everything in Kotlin is seen as an object? Well, objects is something that we're going to go over later, but to give a preview, an object is an implementation of a blueprint known as a class. A class can have a number of different members. These members can be different variables like what you see here, and/or they can contain functions. Each of these variables that you see on your screen here, these are objects, meaning I can do something like this. On the screen, that 4820.7 literal that we have, all I did, since this is a floating point object, in particular a double value, dot, to denote that we're going to use one of the members of the double class, to int. To int is simply a built-in function that allows you to convert a value to an int. So now our code would compile as normal, since an int is going into an int. Another thing to note, something that is pretty cool, is similar to Python, there's a little memory optimization trick that's done when it comes to integers. Integers between -128 and 127 are cached in memory, meaning that if you assign two variables the integer 3, they'll actually point to the same object in memory. We took a bit of a detour, but let's continue on with our other data types. The next one we'll go over is the Boolean type. Booleans are very simple. They're used to represent an object that has two values. That is either true or false. On line 31, we create a variable called accountActive. It is of the Boolean type, and we assign the value true. On line 32, we create a variable called delinquentAccount of the Boolean type and assign it the value of false. Booleans are used a lot when it comes to conditional statements that we'll go over in a bit. We next have the character type. Characters are also very simple. They're used to represent a single character. And to denote a character, we're going to use single quotes. Anything can go in here. We have the character 9, the character A, the character equals, the character dot. What you cannot have is the character null. Reason being, you'll get an error specifying too many characters in the character literal null. Null is not okay. N, however, is okay. What is also okay is \n. Now you may be asking yourself the question, well, why is this different from the null that we had before? Well, it doesn't have anything to do with the number of characters, because anything more than one character is an error. If I have N7, a little Mass Effect reference there, this gives us the same error as if we were using null again. There are just too many characters in our character literal. Character literal, int literal, they all mean the same thing. It is the literal value that you're assigning to your variable. So why is this \n totally fine? The reason for that is very simple. Every programming language, or at least most of the modern ones, have what is known as special characters that are denoted by an escaping \. There are a number of them. \n is used to denote a new line. \t denotes a tab. \b denotes a backspace, and so on and so forth. Characters are all fine and dandy, but chances are you're going to need to print out some sentences at some point in time in your code. To do that, we use the type strings. On line 38 and 39, I've declared two of them. On line 38, I've created the variable name, customer name, of type string, and I have assigned it the value Vincent Valentine. On line 39, I have created another string variable called account description, once again of type string, and I've assigned it another string. Strings in Kotlin, just like Java, are immutable. What this means is string values cannot be changed or have new values assigned to them. Any operation that would transform a string returns a new string object in its place and leaves the old string unchanged. Now, if you remember from earlier, to create an immutable variable, we use the keyword val. To create a mutable variable, we use the keyword var. We have two variables that we created using the keyword var that are of the string type, but strings, regardless of whether you use val or var, are still immutable. You cannot make the string type mutable. As stated before, similar to Java, string values cannot be changed. Any operation that would do so just simply results in you getting a brand new string. For those of you that are going on job interviews, that is probably one of the most common questions that you'll be asked. Are strings mutable? The answer is no. They are always immutable. Strings have what is known as a string template. To create a string template, we simply use a $sign. On line 39, where we create our account description variable, what we have is, in double quotes, checking account for $, customer name. What this tells us is, following this $, we're going to actually look for this variable name here. As we can see here, customer name is on the line before, on line 38, and we've given it the value Vincent Valentine. If we were to print out account description like we do on line 40, what you'll see is checking account for Vincent Valentine. Think of this as the $sign denotes an expression. An expression is something that needs to be evaluated. Upon evaluating $sign customer name, we simply pull the string and place it here. Next, we're going to go over the final data type that we'll cover, and that data type is arrays. An array is a data structure used to hold a fixed number of values of the same type. On line 42, I've created a variable called transaction R, ARR being short for array, where we create an array array is our type. Right here, where you see in between these arrows, we have string. This denotes the type that this array is going to hold, meaning array string is simply going to hold nothing but strings. Equals, we have a built-in function called array of, which allows us to take multiple values and assign them to our variable. The values that we pass into array of is going to be all strings. Now, there is another data structure used to hold a list of things, and that structure is called a collection. Collections come in a number of different flavors. You have lists, you have sets, and you have maps. But for right now, since we're talking about arrays, we're going to talk about lists. On line 45, I've created a variable called transaction list. We're going to use array list string, denoting that we're going to create an array list of strings. And we're going to use the built-in function array list of. We're going to pass the same exact values as we did for our array. Now you may be wondering, well, if they're both meant to be the same thing, then which one do you use? More often than not, you will more than likely be using collections. The reason being, arrays are a lower level data type that tend to be more performant. If you don't need something that is super performant, collections can be used instead. Adding and removing elements from a collection is a lot easier too. Given that arrays are fixed in size, the only way to add or remove elements in an array is to create an entirely new array each time, which is obviously inefficient. Now, as you can see here, I'm going to show an example of what I mean. On line 43, we have transaction array plus equals to denote that we are going to add another string to our array. Plus equals the string Hulu subscription. In our output, we can see that on lines 44 through 47, we're printing out the contents of our array. And the contents of that array are Amazon, Crunchyroll, Nintendo eShop, and Hulu subscription. As I stated earlier, arrays are fixed size, meaning that whenever you add or remove, what you're actually doing is creating a whole new array with your changes and reassigning that new array to your variable, which once again is obviously very inefficient. Compared to, as we see here on line 46, transaction list.add Hulu subscription. This method that you see here, .add, is just a built-in function for array lists, which, as the name implies, allows us to add a new element to our array list. The benefit here is we're not creating a whole new array list and just reassigning it. We just simply add this new string element here to our existing list. To see all these different values, you'll of course need to print these things out. As you've seen before, if you want to print something out, print line, which is a simple built-in function in Kotlin that, as the name implies, prints a line to the screen. On lines 49 through 51, we have some very simple print statements, which print on line 49, bank ID, which prints out our bank ID number that we have on line 24 here. On line 50, print account bal, which is going to print out our account balance from what we see here on line 27. Line 51, account active, question mark, followed by our string template with a little bit of pizzazz added to it. So we have $, curly brackets, followed by an expression inside of it. What we have here is if account active we're going to print yes, else we're going to print no. This is a little sneak peek of another section that we're going to go over called conditional statements. What this is saying is if account active has the value true, which it does from up here on line 31, we're going to return the string yes. Else, we're going to return the string no. As you can see here on line 51 in our printout, account active question mark, and we have yes here because account active is true. If we change it to false, we see account active is now no. Printing out the contents of your collections is a little bit more involved. To print out each of your elements, what you're going to do is use the built-in function that collections have called for each. So we have print line t, which over here on lines 52 through 55, what we are going to be printing out is the contents of our array. And as you can see, the contents are Amazon, Crunchyroll, Nintendo eShop, and the Hulu subscription that we added. In this section, we're going to cover the operators that you'll find in Kotlin. You have your basic arithmetic operators, addition, subtraction, multiplication, division, and modulus division. Addition, subtraction, multiplication, and division should be pretty self-explanatory, but if you've never heard of modulus division, all that is division where we just take the remainder and store that. Or print it to the screen, whatever you're going to do with it. So for instance, you have 5 modulus 2. All that's simply saying is divide 2 into 5 and take the remainder, which would be 1. We have our more interesting conditional operators. We have our less than operator, our less than or equal to operator, greater than or equal to, equality, structural, inequality, also structural. The difference between these two is equality and inequality for the structural side. It's just simply us comparing the values of two things. We're asking, are these two things equal value? So for instance, if we were to print 2 equals 2, that is of course true, as we'll see here. Inequality, does 2 not equal 1? That is also true. On line 21, you see we're printing out, does 2 equal to 2? We know that this is true. To make things a little bit easier, I have changed line 23. We're going to print, does 2 not equal to 2? Think of this as, does 2 equal to 2? That is of course true. Now, the inverse of that, or to negate that, would be to take that true and inverse it and turn it to false. We can do the same thing here, how we've changed on line 21. Print, does 2 equal to 3? It does not, so we print false. The inverse of that, we're checking the same two numbers, except we're using inequality. So we know that 2 does not equal 3, which will result in a false. Inverse that to make it true. Well, the same thing applies for referential equality and inequality as well. The difference between structural equality and referential equality is that structural equality just simply checks once again that two things are equal to each other in value. 2 equals 2, 3 equals 3, 2 does not equal 3, so on and so forth. Referential takes it a step further. Referential is checking to see if the two items that we are comparing occupy the same space in memory. You may notice this squiggly line underneath our comparison on lines 25 and 27. That is because in Kotlin, identity equality or referential equality for arguments of type int, that is depreciated. Long story short, in Kotlin, what you see on lines 25 and 27 gets translated to what you see on lines 21 and 23. Basically, the identity or referential equality just gets translated to structural. Now, these operators are fun and all, but without some means of actually making use of these outside of print statements, they're not all that useful, right? So that's when we move into our next section. In this section, we're going to be covering control statements. Now, when it comes to control statements, think of them as means of controlling the flow of execution in your applications. With control statements, you can execute certain things based off of a given condition, like what we'll be seeing with the if, else statements. You also have different flavors of loops, which we'll cover shortly. For now, let's take a look at if, else statements. In our first example, on lines 7 through 9, you can see that I've created 3 different int variables. We have cart balance set to 2000, transaction amount set to 100, cart limit set to 4000. So to create an if statement, we're going to of course start with the keyword if, followed by parentheses. Now, inside of those parentheses, we're going to give some conditional statement. The conditional statement that we're using on line 11 is, in parentheses, cart balance plus transaction amount. If that is less than or equal to the cart limit, we're going to print purchase successful. Else, we're going to print rejecting transaction. To break the statement down a little bit further, inside of these parentheses, think of it as order of operations. How I learned it in school was, please excuse my dear Aunt Sally. Meaning we execute whatever's in parentheses first. That applies here as well. In this statement, we have inside of parentheses, cart balance plus transaction amount. That means that we're going to do this addition here first, and then we're going to do our comparison. So cart balance is 2000, transaction amount is 100, so this is 2100. And we're going to check if that is less than or equal to our cart limit. Cart limit is 4000. On the right side of the screen, we can see the output. Since 2100 is less than or equal to 4000, we print purchase successful. In our second example, we're going to create on lines 18 and 19, 2 new variables. We have checking account balance, which we give the value 300, and min account balance, which we give the value 300 as well. On line 20, we change the transaction amount to 2000. On line 22, we're going to create an if, else statement. On 22, where our if statement starts, we have if the checking account balance is less than the minimum account balance. What this is saying is if 300 is less than 300, it is not. They're equal. So we won't be printing account is underfunded. Since that condition didn't pass, we now move into the next statement, which is our else if statement. We have in parentheses, checking account balance minus transaction amount is less than or equal to 0. Checking account balance is 300 once again, and the transaction amount now is 2000. So we have negative 1700. And we're asking, is negative 1700 less than or equal to 0? That is indeed true. So, as we can see over here on the right side of the screen, we print account is now overdrafted. In our third example, as you can see, we add one more else if statement. Now, when it comes to else if statements, we can have as many as we want. We can have one, we can have none, as we've seen before. we can have 100. Not practical, but we can have 100. In example 3, we have 2. On line 31, we start our if statement. If checking account balance, which is 300, is equal to 0, then we're going to print account is not in good standing. Else if checking account balance is greater than 0 and checking account balance is less than or equal to minimum account balance, we're going to print account is in good standing. Sorry, account is in decent standing. Else if account balance is greater than minimum account balance and checking account balance is less than or equal to 2,000, we're going to print account is in good standing. Else, print account is in great standing. Since our checking account balance is 300, we know that our if statement won't execute. So we move to the next else if statement. Checking account balance is indeed greater than 0 because 300 is greater than 0, and checking account balance is less than or equal to minimum account balance, which is 300. So we print account is in decent standing. We don't bother with the else if statement or the else statement because any subsequent checks that we have, we can ignore them because we've already found our condition that matches. Now, our conditional operators that we've gone over thus far, greater than, less than, greater than or equal to, less than or equal to, these are known as comparison operators. When we're looking at equal to and not equal to, these are what's known as equality operators. This ampersand ampersand that you see here, this is a logical operator. Logical operators are used to compare two or more statements, and a Boolean value is returned. We have 3 in Kotlin. We have, as we've seen here, ampersand ampersand, which is our AND operator, 2 vertical lines, which is our OR operator, and we have an exclamation mark, which is our NOT operator. To make things easier to visualize, I have made the following statements. On line 41, we can see T, which represents true, and T is going to equal to true, whereas true and F, which is short for false, is going to always equal false. Meaning, whenever we are making use of the AND operator, if we detect a false, the whole statement is false. There's also a shorthand that we also use. In this third statement, we have F and T equals F. If the first statement that we're checking is false, there is no need to check the second one. Since we found a false, it's going to be false regardless of if we check the second statement or not. The OR operator is a bit more forgiving. When working with the OR operator, the only time an OR expression results in a false is if both statements are false. If both are true, we of course get true back. If so much as one is true, then we're still going to get true back. We only get false once again if both statements are false. Not is one that we've seen before, and is the most simplest of the 3. Unlike AND and OR, which are both binary just simply meaning the operator has 2 operands. There's an operand on the left and there's an operand on the right. The NOT operator is unary, meaning it only takes 1 operand. Not true is false. Not false is true. Very simple, right? And of course, you can also mix and match these like such. On line 44, I have the following conditional statement. true and true, or not false. Now that may have sounded like complete and utter gibberish, so we're going to actually break down what this is, which is what we see highlighted here. Remember, what we have in our parentheses gets executed first. And inside of our parentheses, we have true and true, which as we've seen up here, is equal to true. So we get this true over here, or true or not false. Remember, not false is true. So we have true or true, which we know that true or true is equal to true. So this complicated statement here translates to true or true, which is true. Some things about the basic structure of the if, else statements is that else if statements are optional. So is an else statement. We can get rid of the two else if statements and the else statement, and this is perfectly fine. Just wanted to clarify that before we move on to our next example. In our next example, on line 42 through 44, we're going to create some more variables. On line 42, we create a max character variable, which we assign the value 15. On 43, we create a min characters value, and we assign it the value 5. On 44, we create a string called name and assign it the value tech construct. On line 46, we have the conditional statement name.length is less than min characters, or name.length is greater than max characters. We're going to print supplied name must be between min characters and max characters, else we're going to print welcome name. Our string has 14 characters. The 4 characters from tech, our empty character, that makes 5, and the 9 characters from construct, which gives us a total of 14 characters. Since 14 is not less than min characters, which is 5, this is false. Since we're using or, we have to check the second statement. 14 is not greater than max characters. So we do not print this statement out. As we can see, we print what is in our else statement, which is welcome name. Now in our fifth example, this is more so to show you that conditional statements in Kotlin can also be used as expressions. Expressions being if returns a value. On line 53, I've created a variable a, which I assigned a value 10. On line 54, I've created another variable called b, and its assignment, depending on if a is equal to 0, it's going to be 20, else it's going to be 30. 10 does not equal 0, so 30 is what gets returned to b. On line 55, we print out the contents of b, which as we can see over here, is now 30. Our next control statement that we'll be going over will be the when statement, or when expression. The when expression, denoted by the keyword when, matches this argument against all branches sequentially till a branch condition is satisfied. On line 50, we've created a variable named num, and we've assigned it the value 1. To create a when statement, we use the keyword when, open parentheses, some statement, and close that parentheses. In this case, when num, and you can see here on lines 52 through 54, we have our cases. These can be read as when num equals 0, we're going to print the statement the device is off. When num is equal to 1, we're going to print the statement, the device is on. Else, we're going to print the statement, what's going on with this device. As we can see on line 50, num is equal to 1, which means the statement on line 53 is going to get executed. On line 57, we create the variable name and assign it the value Akira Toriyama. On line 58, we create the when statement. When name equals Akira Toriyama, we print the statement, rest in peace. Else, we're going to print unknown person. Name equals Akira Toriyama. As such, we're going to print rest in peace. On line 63, we create another variable named state, and we assign it the Boolean true. We have the when statement on line 64. When state is equal to true, we're going to print you pass. On line 66, when state is false, we're going to print try again. Now, you may notice that our third when statement is different from our first two. The reason for this is our third when statement does not have an else case. When you have a statement where all possible branches have been accounted for, you don't have to use an else case. In the case of state, there are only two values since we're using a Boolean. That's true or false. We have a case for true, we have a case for false. Therefore, an else statement isn't needed. But in the case of something like a string or a number or some other kind of condition that can have multiple branches, you either must account for every single branch, which in the case with our first when statement, we have an integer. You would need to account for a few million conditions. No one has time for that, so we use an else case to just give a few of those cases and be done with it. The same with string. You'd have to account for every iteration of a string. I'm sure you don't have time for that, so once again, you give the conditions that you will account for and an else as a catch-all. Finally, we'll be covering loops. As the name implies, a loop allows us to do something, of course, on a loop. When it comes to loops, we have three different flavors in Kotlin. We have my personal favorite, the for loop, which is denoted by the keyword for. We have while loops, denoted by the keyword while, and do while loops denoted by the keywords do and while. We'll start with the for loop. On line 78, we create a variable list of stocks, and we're going to create an array list of strings. Those strings being NVIDIA, Reddit, Microsoft, and Apple. These are their tickers on the New York Stock Exchange, S&P 500, so on and so forth. On line 80 is where we create our actual for loop. We'll start by using the keyword for, open parentheses. We're going to create some variable that will serve as a placeholder. In, followed by our collection. What this statement is saying is that for every value in our list of stocks, we have for every value, we're going to execute our statement. And that statement is printing out stock. If we were to loop through this, what we have is stock in list of stocks. So first, we're going to take this first value here, and we're going to store it in our placeholder variable stock. So stock will equal NVIDIA, and then we're going to print the value that is in stock, which is NVIDIA. That's now done. So now we move to the next one in our loop, which would be Reddit. We're going to print that stock. Move on. Next is Microsoft. Microsoft gets stored in stock. We're going to print stock. Move on to the next. Apple gets stored in stock, and then we're going to print stock, which will be Apple. I created another for loop to showcase a different way of providing a condition. On line 82, we're going to create an integer called x. What we're saying is x in the range of 0 to 10, we're going to print x. Since we're giving the range 0 to 10, what's going to happen is x is going to be given the value 0, since that's where we start in this range. So in this for loop, we give the range 0 to 10. We're going to print out the values between 0 and 10. To trace this, 0 will be placed inside of x, since that is the start of our range. We print x, which is going to be 0, and then we go to the next one, which will be 1. 1 gets assigned to x, print x, which is going to be 1. We do this so on and so forth until we hit 10. We print 10, then we stop. Once we hit 10, we print 10, and that's the end, since our range is from 0 to 10. You may also notice that on line 80, I don't use curly brackets as opposed to on line 82, where I do use curly brackets. The reason being is if it's just one line, you can simply do it this way. Your conditional statement on the same line as whatever your execution block is going to be. What's inside of this curly brackets that you see on lines 82 through 84 is just the execution block. Once again, since it's just one statement, you can shorten it to be all on one line. Now, of course, what's on line 80 isn't going to work when you have multiple statements that you need to do. It can be something as simple as printing multiple print statements or doing some calculations like so. Moving from for loops, we have the while and do while loops. While and do while essentially do the exact same thing with one key difference. While checks the condition, and if that condition is satisfied, we're going to execute the body. Do while does the opposite. Do while executes our block and then checks to see if our condition is satisfied. Another way of putting it is while is a pre-check, whereas do while is a post-check, meaning at the very least, we're going to execute our block at least one time with a do while. To illustrate the difference between the two, I'm going to change index to 10. Now we have the statements while 10 is less than 10. Our condition isn't satisfied, so we don't do anything. On line 97, we're going to change our index to 10. Do print 10, increment by 1. While 11 is less than 10, we know this to not be true, so we're going to break. In this section, we'll be covering packages and imports. Your package can contain source files, which are just basically files that contain your code, like so. It can be text files, it can be JSON files, images, whatever have you. Think of your packages as a folder that contains other folders and files. Inside of each of your source files, you're going to have on line 1, typically on line 1, your first executable line is going to be denoting the package that that source file is in. On line 1, we see package com.techConstruct. That comes from inside of the directory of our application here. We have inside of our source folder, we have a main folder, which has a Kotlin folder. And right here, which is the start of our package, we have a com folder, which contains a tech construct folder, And that tech construct folder has our Kotlin source file demo. Now, inside of our utils folder here, we have a utils Kotlin file, which, as you can see on line 1, package com.techconstruct.utils, denoting that this source file is contained inside of our utils package, which is inside of com.techconstruct. Inside of our demo Kotlin file, we have a simple function, which is our main function here. And in that function, we just have the creation of a value, name, give it the string value Lucian. And on line 7, we do a call to a function called print greeting, passing in a name that we have here on line 5. Now, you may be wondering, where does this print greeting function comes from? Well, that is simple. Here on line 2, you can see that we're importing from com.techconstruct.utils this print greeting function. If we go inside of our utils file, we'll see this function here. Function print greeting, which has a parameter called name, which is of type string, and we give it a default value of techconstruct. Inside of this function, it just prints hello, whatever the name that we pass in is. Since we imported that print greeting function, we can now use it inside of our demo file. When it comes to importing, there are some default imports that are done. For instance, this print line function that we've seen constantly throughout this video, this actually comes from the Kotlin.io package, which is imported by default inside of every Kotlin file that you'll create. Now, you may look at this and be wondering, what is this function thing that you're talking about? Let's go over that now. To start, functions are declared using the keyword fun, as you can see here. Our syntax is fun, followed by the name for a function, followed by parentheses, colon, some value type if we're creating a value returning function. So as you can see, we create a function called addNumbers, which takes in 2 parameters. X, which is int, which has the default value of 0, and Y, which is also an int, which has a default value of 0 as well. Inside of our function, we're just simply going to return X plus Y. Now, not all functions have to return a value. These functions typically just print something to the screen or change something where we don't care about what the value is. On line 11, we create a function called viewPoint. That viewPoint takes in 3 parameters: an X coordinate, a Y coordinate, and a Z coordinate. All of them are ints, which have the default value of 0. On line 12, we can see that our function simply prints the point is at parenthesis, string template X, string template Y, string template Z. If your functions are as simple as these two here, where there's just a singular line that's used, we can create a single expression function. On line 16, we see how we do that. And it's extremely simple. We start with our keyword fun. We give a function name. I'm choosing subtract numbers. Subtract numbers has 2 parameters, X and Y. Both are integers and both have the default value of 0. Colon, our return type of int, followed by equals. And what we're going to assign to this is X minus Y. If we were to simply convert our addNumbers function to the same format, it would look like so. Function addNumbers, our parameters, colon, return type equals X plus Y. Creating functions is all fine and well, but you're going to have to make use of those functions and we make use of a function by calling it. On line 16, I've created a value, result, and I'm going to assign it the value that is returned from our addNumbers function above. To call a function, we take that function's name, parentheses, any arguments that will be expected. Since addNumbers has two parameters, we're going to pass the two arguments 59, which represents X, and 18, which represents Y, meaning 59 is going to be stored inside of X, and 18 is going to be stored inside of Y. Since our addNumbers function is value returning, this X plus Y is going to be returned and stored inside of our result value. On line 17, we print the contents of result, which will just simply print 17. You can skip the process of creating a new value by simply calling that function inside of a print statement. The result is still going to be the same because this is no different if you were to replace this function call with 59 plus 18. Since this returns a value, we're simply going to print that value. On the other hand, on line 19, where we call our viewPoint function, we pass in our arguments 59 for X, 13 for Y, and 9 for Z. Since it doesn't return a value and simply prints out a statement, when we call this function, on the screen, we'll see the point is at 5, 13, 9. Now, going forward, there are two things to clarify. The first is the difference between a parameter and an argument. In the beginning, you're going to hear these two terms used interchangeably. If you're in a freshman programming class and you're talking to other freshmen, chances are you're going to hear parameters and arguments being used interchangeably. This is wrong because parameters and arguments are two different things. Parameters are placeholders. They also help to define our function signature, whereas arguments are the actual values that we pass to our functions. Our addNumbers function has the parameters X and Y. Our viewPoint function has the parameters X, Y, and Z. Our subtractNumbers function has the parameters X and Y. And down here where we make our calls to our functions, addNumbers, we're passing the arguments 59 and 18. For our viewPoint call, we have the arguments 5, 13, and 9. Now, it is entirely possible for a function to not have any parameters at all, like so. On line 21, I've created a simple function, say hello, which has no parameters. It just simply prints, hello, konnichiwa, hola, bonjour. Now, that was the first thing, parameters versus arguments. The second thing is, up here on line 8, where we have our viewPoint function, you'll see here void/unit function. During the explanation of this function, I stated that there was nothing being returned here, as in it's not value returning. That is not technically true. A function that doesn't return anything useful has the return type of unit. Unit is a type that has only one value, and that's unit. This value doesn't have to be explicitly returned, nor does it need to be explicitly declared. Here in our viewPoint function, what you see here on the screen is the same as on line 12. I simply made a copy of the viewPoint function and added the return type unit. Now in your IDE, if you were to hover over it, as you can see, unit here is grayed out. That is because it is redundant. If you are in an IDE like IntelliJ and you were to hover over unit, you'd see the message redundant unit return type. That is because it is implied that since we don't return anything, it's of type unit. Now, on line 23, you see that we're printing out another call that we make to our add numbers function. Except this time, you may notice something slightly different. Compared to our call up here on line 17, where we have add numbers passing in the arguments 59 and 18, here on line 23, we're making a call to add numbers, and we make use of what is known as named arguments. Named arguments are a way of passing values to our functions in any order, and using them is simple. We know that the parameters that our add numbers function takes in are x and y. A named argument is just simply making use of those names. So you see x is equal to 4, y is equal to 7, and it tends to make things a bit easier to read and slightly less error prone. Because let's use another example. On line 25, I've created a new function. That new function just simply divides whatever two numbers that we pass in. Like our add and subtract functions, they take in an x and a y, return an int, which is the division between x and y. On line 27, we print whatever is the result of calling our divide numbers function with the arguments 5 and 0. So 5 is passed to x and 0 is passed to y. So what we have is 5 divided by 0. Except we know that we cannot do that. You can't divide a number by 0. In fact, an exception is going to get thrown. You're going to get what is known as an arithmetic exception. Can't divide by 0. Now, we can fix this, but wait, this actually isn't what I wanted. What I actually wanted was to do 0 divided by 5. Well, simple way to fix that is, here on line 28, we call divide numbers passing in the arguments 0 and 5. 0 is going to go to x, 5 is going to go to y, and we fix our issue. Except not quite. A better way of handling this would be to use named arguments, like so. This way we remove the ambiguity. You can even do this. You notice how on line 30, our first argument, y is equal to 5, and our second argument, x is equal to 0. Well, this is the exact same as line 29, because named arguments, when we're using named arguments, it doesn't matter what order we use them in. Because our code knows x is still going to get the value 0, and y is still going to get the value 5. It doesn't matter how you change these up. Now, in order to use named arguments, default arguments are required. A default argument is just simply what you see here for each of the functions that we've created. Divide numbers on line 25, subtract numbers on line 13, you see the default value equals 0 for each of our parameters. On line 25, x has a default parameter 0, and y has a default parameter 1. A default parameter is just some value that you plan to use if nothing is passed in. So for instance, let's change our default parameters in the divide function to x defaulting to 4 and y defaulting to 2. It becomes perfectly fine for me to do like what we're doing on line 27. Print divide numbers, and I don't pass anything in. Since I don't pass anything in, our function is going to use the default parameters 4 and 2, and the result will be printing 2 to the screen. And of course, you can also do the same thing with strings, doubles, floats, any value really. As you can see on line 29, we have a function called greetings, which has a parameter called name of type string, which has the default parameter tech construct. On line 31, we just simply make use of our default parameter, which is tech construct, meaning when we call greetings without passing anything in, we'll print out hello tech construct. On line 32, we use named arguments, name equals Jonathan. So when we call this function, we print hello Jonathan. And on line 33, we just pass in a simple argument to our function since it only takes one. And that results in us printing hello Virgil to the screen. Our next topic of discussion will be lambdas and anonymous functions. To put simply, lambdas and anonymous functions are just nameless functions that we use for typically performing some rather simple tasks. They're meant to be more so throwaway functions. Lambdas and anonymous functions are function literals, or just simply functions that are not declared but are passed off immediately as expressions. On line 4 and 5, I've done something that we should be pretty familiar with at this point, which is declaring variables. We have two different ways of doing that. Using our keyword val for immutable, or var for mutable, followed by the variable name, and we can do colon, give a type, equals, whatever value that we're going to pass in. We're creating an integer variable, and we're going to assign it the value 9. We do the same thing on line 5, but we just omit the colon integer portion. Well, we can do the same thing when we're creating a lambda. For lambdas, their expressions are always surrounded by curly braces. So this open curly brace here and this closing curly brace here, what you see inside is our actual lambda. Parameter declarations go inside the curly braces and have optional type annotations. As we can see, we have two parameters here. We have an x of type integer and we have a y of type integer as well. Now the body of our lambda goes after this arrow operator that we see here on line 8. On lines 9 and 10, we see the actual body of our lambda. On line 9, we're going to print inside of our lambda. And on line 10, we have x plus y. A thing to note is that if the inferred return type of a lambda isn't unit, the last expression inside of the body is treated as the return value. Since x plus y is our last expression, we know that x plus y returns an integer, which means that what this lambda is going to return is going to be an integer. Now this lambda gets stored inside of this variable that we created called sum. On line 12, we're doing the same thing in the same sense that we do the same thing on line 5 compared to line 4. The only difference between line 8 where we declare sum and line 12 where we declare sum2 is that we leave out the optional specifying of the type that sum is going to be. That sum2 is going to be. We have sum2 equals a lambda that has an x and a y parameter and returns the value x plus y. Well, this here that I have highlighted, what's inside of this curly brace? It is implied that the type of sum2 is some function literal that takes in two integers and returns an integer. Sum and sum2, for all intents and purposes, are functions. So as we see on line 14 and 15, we have print line sum, open parenthesis, 8 and 9. This 8 is going to be stored inside of our x, and this 9 is going to be stored inside of our y. The end result of this function call here is going to, of course, be x plus y. So we're going to print 17 to the screen. The same exact thing happens with sum2. We pass in two arguments, and those two arguments are going to be added together, And since this is inside of a print line, we're going to print 39, since 19 plus 20 is 39. Now on line 18, we're going to create a new variable called diff, and its value is going to be an anonymous function. Note that anonymous function is more or less declared the same way as a regular function. It's just that anonymous functions, as the name implies, these functions don't have function names. So we have function, open curly braces. We have our parameters that we're going to take in, two integers, x and y. And that function is going to return a value. It's going to return an integer value. Our curly braces are here to denote that we are starting our function body. On line 19, we're going to print inside a non-function. And on line 20, we're going to return x minus y. On line 22, we're going to print diff, since diff is no different than a normal function, parentheses 30 and 16. 16 from 30 is going to be 14, so we'll print that to the screen. Now, you'll look at anonymous functions and lambdas, and these seem to more or less be the same thing, correct? We're just basically dealing with functions. But what is the difference? Why would we use one versus the other? Well, one of the key differences between a lambda and an anonymous function is the usage of the keyword returns. If I were to add return to line 10 like so, you see that we get an error. Well, if these are supposed to be the same thing, then why would we get an error here on line 10 and not get an error on line 20? Well, this is because how the keyword return works. Return is going to return us to the nearest function declaration. And that function declaration is returning us to the last function declaration that used the keyword fun. So when we say return x minus y, this return here marks the end of our function. That is different on line 10 because, as we can see, there is no fun keyword used here. A lambda is, for all intents and purposes, a function, but it just operates a little differently. Most of the time, lambdas are typically the preferred way to go. To further illustrate, and also to teach something new, what we've discussed about lambdas and anonymous functions, I have created a series of variables. On line 5, we create a variable called list of colors. List of colors, we use the array list of function, and we're going to pass in a number of strings. And those strings are colors. Nothing too different from what we've done before. However, on line 8 and 9, you see the first usage of something that we haven't made use of before. And that is called a set. Now, when it comes to sets, think of a set as basically a list that doesn't allow for duplicate values. If I want to have red in this array list of strings 40 times, then red is going to be in this array list 40 times. As opposed to our set, where we have an example of that on line 9. On line 9, we have set of strings, which makes use of the hash set of function, where we're going to be passing in a number of strings of things that I have growing in a garden. We have strawberry here twice, bok choy here once, carrots here twice, and tomatoes here twice. Well, the end result of this would be, when we're creating this hash set, any duplicates would get dropped. So in actuality, set of strings actually just contains strawberries, bok choy, carrots, and tomatoes. So once again, a set is essentially a list that doesn't allow duplicate values. On line 12, we're going to make use of another new form of collection, and that form is called a map. Think of a map as a list of key value pairs. Each element inside of our map has a key and it has some value. On line 12, we have map of books equals the return from the function hashMap of, where we pass in a number of pairs. A pair in Kotlin is just basically a generic pair of two values. So we have two values that we're going to pair up. Remember that I said that a map is a collection of key value pairs. So with our pair, the first value that you see here is going to represent our key. The second value that you see here is going to represent our value. So we have a hash map of string keys and string values. Forgot to change this. That is probably confusing you. With a map, since our key is book 1 and book 2, if I want to access the value World War Z, I would do this. Map of books, bracket notation, and we'll use the string book 1 as our key. And that will give us World War Z. Now your key can be whatever you want. Same with your value. So long as you know how you're going to make use of that key, you can make maps as complicated or as simple as you want. For the sake of our example, to keep things simple, I'm going to make these keys integers. One thing to keep in mind is that lists, sets, and maps all come from the same family, and that family is called collections. Anything that is a collection, so lists, sets, and maps, have the function for each, and they also have another function called filter. On line 16, I have list of colors dot for each. This for each is a function that takes in a function literal. So we can create a lambda and pass that in, because more often than not, I would say 99.9% of the time, you probably don't want to create a function specifically for a for each function. Our for each function takes in a function literal, so we're going to make use of a lambda. Remember, your lambda is denoted by curly braces, and inside of those curly braces is going to be the actual lambda itself. However, you're going to notice something a little bit odd. We don't have any parameters listed here. In fact, on line 17 and 18, you see us making usage of something called it. Well, what is it? There's a shorthand that's used in Kotlin. When it comes to our lambdas, for each takes in a function literal that just has one parameter. Remember, our function literals are just functions. So what you're basically saying is, for each takes in a function that is going to have a single parameter. Whenever we're dealing with this case here of an expected function with a single parameter, we don't need to specify the parameters list. This it that we see here is an implicit name for that single parameter that is going to be expected. For each and filter expect the exact same thing. They're expecting a function literal that has a single parameter. Since they're expecting a function literal with a single parameter, we don't need to specify that parameter and we can just use it. So on line 16, list of colors dot for each, our lambda. Inside of that lambda, what we're going to do is print the color is, and then we're going to make a call to another function that I created just to make this cleaner. Print color message, passing in the value stored inside of it. For each works just like the loops that we've gone over before. So we know that for each element inside of list of colors, we're going to perform the actions on line 17 and 18. So we start from index 0. The string is red. So we print the color is red. And then we pass red, our string red, to print color message. Print color message is just a simple function that takes in a string for color, and it has a when statement inside of it. When color is red, we're going to print icon Phoenix. Depending on what color we pass into this function, we're going to print a different message. We're inside of a loop, so we're actually going to make use of all those cases. We had a case for red, blue, green, and black, so we're going to end up printing out each of those statements. Next, we're going to make use of our sets. On line 21, we have our set of numbers, which is just a hash set of numbers. And on line 22, we have our hash set of strings, which is just a hash set of strings. Method 1, we're going to make use of a lambda. We have on line 25, lambda filtered set equals set of numbers dot filter it in range of 5 and 20. So if it is greater than or equal to 5 and less than or equal to 20, this number is going to be added to our set. Before we move on, just want to explain a little bit more about this filter method that we're using. Filter returns a list containing only the elements matching the given condition that we set. That condition is if that number is in range of 5 and 20. What filter is going to do is then return us a list of all those numbers that fit that criteria. If it's true that it falls in range of 5 and 20, it's going to get added to the list. If it doesn't, it's going to get excluded. So this should actually be lambda filtered list. Moving on line 26, we just print method 1, not 2. And on line 27, for each element inside of that lambda filtered list, we're just going to print that item. On line 30, I create another variable called a non-filtered list, which is going to equal set of strings dot filter, and we're going to pass in an anonymous function here. That anonymous function, item of type string, and it is going to be returning us a Boolean, which is what filter wants, equals if the item dot length is in range of 2 and 7. So if any of these strings here, if the length of these strings is between 2 and 7, it's going to get added to our non-filtered list. If it's outside of that range, it's going to get excluded. We print method 2, a non-filtered list dot for each. We just print out whatever the contents are. On line 34, we print regular print of set of strings. And this is just to show you that sets will completely ignore any duplicate values. That's the end of sets, and we'll move to maps. On line 37, we have map of books dot for each, and we're going to make use of a lambda. That lambda, we're simply going to print the key, and we're going to print the value. Now, when it comes to maps, there is what's known as an entry. That entry represents another pair. That entry has an integer key and a string value. That's what this means here. So it, in the context of our map, contains an entry, and we can use it.key, which is going to just simply print whatever the key is. It.value is going to print whatever the value is. So for each, we have our pair here. It contains a map entry of 0 and World War Z. So it.key is going to be 0. It.value is going to be World War Z, the string. On line 43, pretty much the exact same thing. I just wanted to point out the usage of this underscore here. So when it comes to maps, we have our for each, similar to how we had on 37. On 48, you see we're using another lambda, but the difference that you see here is we're actually going to specify the parameters list. Since I don't really want to make use of the key, I'm going to use this underscore to denote that I'm not going to be using it, so that I can just use the value. Now, the only difference is that you'll see that line 43's book data map is a hash map of key value pairs with string keys and book data values. Book data is just simply a data class, which is something that we'll go over later, but just think of this as an easy way to have a collection of different values. Inside of this book data, we have a string called name, a string called author, and we have an integer called year published. To reference each of these things, you see on line 49, we have print line author. Author, string template v.author. To print the title or the name, v.name, and to print the year published, v.year published. To close up this section, I also want to go over what is known as trailing lambdas. On line 56, I have a list of books, and that list of books is an array list. An array list of those same book data objects that we've gone over before. That book data has a name, which should be title, an author, and a year published. We have Steal Like an Artist by Austin Kleon, Missing 411 by David Paulides, 1984 by George Orwell, War or Z by Max Brooks, and Parable of the Sower by Octavia Butler. On line 64, you see that we have another variable that we create, filtered books. List of books, which we have up here. List of books.filter. Our first filter is going to be if the year published is in range of 2000 and 2020. Now remember, filter is going to return us a list. So it's perfectly fine for us to use another filter by way of .filter and add another filter onto that list. The second filter is if the character count of the name is in range of 5 and 20. So we do one filter based on the year published, and we do another filter based on the length of the name. Whatever is left after both of those filters is going to get added as a list into our filtered book list. Showcasing all of our output, you see, given our list of colors, array list of the strings red, blue, and green, and black. What we're going to do is for each of those, we're going to print some statements out. As we can see in our output here, we have color is red, icon Phoenix, color is blue, icon Shiva, color is green, icon Garuda, color is black, icon Bahamut. And then we print end of list printouts. Next, print method 1, lamb filtered list for each. We're going to print out the contents of this list. So we have a hash set of 13, 20, 27, 34, 3000, 2024, and -4. And we want to filter out all the numbers that are not in range of 5 and 20. So at the end of that filter, we are left with 20 and 13. As we can see, 27, 34, 3000, 2024, and -4 do not fall into this range, so they get excluded, and we print out what is left. Now, method 2, using our anonymous function, we're going to print whatever is left after our filtering of our set of strings. That filter is if the item.length, which is just the size of our string, is within range of 2 and 7. So the only thing that we have is carrots. Print line, regular print of set of strings. And as you can see, we just print strawberries, carrots, bok choy, and tomatoes. Because once again, when you're creating a hash set, any duplicate items get dropped. We print end of set printouts. Next, we're going to go over our map printouts. Line 35, print method 1, As we can see here, key is 0 and value is World War Z. As we can see from this pair here, key is 1, value is Steal Like an Artist, which is our pair that we can see right here on line 34. We move on to method 2, which makes usage of our map of book data. We have author, Austin Kleon, title, Steal Like an Artist, year published, 2012. We have author, David Paulides, title, Missing 411, year published, 2012, which we can see is the format of output that we have inside of our Lambda. And then we print end of map printouts. For our filtered list, we have Steal Like an Artist, Missing 411, and Parable of the Sower. Remember, our filter is year published in range of 2000 and 2012. 1984 is off the list thanks to that filter, but everything else remains. So next, name.length is in range of 5 and 20. World War Z and oral history of the zombie war is obviously going to get knocked out. So what we're left with are the three books that you see here: Steal Like an Artist, Missing 411, and Parable of the Sower. In this section, we're going to start covering classes. There are two concepts that work in tandem when we're talking about classes. Those concepts are classes and objects. Think of a class as a blueprint, and an object is just a creation of something following that blueprint. In comp sci terms, we instantiate an instance of a class to create an object. As you can see on the screen here, I've created a class called person. To create a class, we start with the keyword class, and we give a class name, which is in Pascal case. Pascal case just simply being the first letter of each word is capitalized, whereas the other letters are not. So for instance, if I were to have a class person class, it would look like this. Next is an optional primary constructor, which we can see here. Classes can contain class fields or variables, class functions or class methods, and even other classes. They can also contain what are known as constructors and initialization blocks. And as we're already aware, when we're creating variables in Kotlin, it's better to initialize those variables. As you can see here with my class fields on lines 8 and 9, we create two variables. On line 8, we create a variable ID and assign it the value hashcode. A hashcode is just a random integer that is generated in every class. On line 9, we create a string variable called species and we assign it the string human. Now, when it comes to initializing variables in our classes, we have two ways of doing that. Our first way is through constructors. Constructors are functions that are called when an object of a class is instantiated or created. Whenever you hear me use the word instantiated, just think of created. These typically house code that is used to initialize class variables or fields. There are two flavors of constructors. We have what is known as primary constructors, which we see here. Every class has one primary constructor. Primary constructors are declared in the class header. The class header is just what you see here, what I've highlighted on the screen. In the case of our persons class, we have the class header class, person, and then our default constructor, which has two parameters, name string and age, which is an int. Now, when it comes to a constructor, every class has one, but you don't need to explicitly declare one. So for instance, I can get rid of the declared primary constructor and our class is fine. As you can see, there are some things that are red, but those are easy to fix by just taking those parameters that we had in our primary constructor and just putting them inside of the actual class itself, making those class members. A class member is just anything that's inside of a class. Any function, any variable, any other classes that we may have inside, so on and so forth. Our second flavor of constructor is what is known as a secondary constructor. On line 20, we define a secondary constructor using the keyword constructor. A constructor that will have a list of parameters or no parameters at all, followed by a colon, followed by the usage of this new keyword that we have, this, parentheses, a number of arguments. Pay close attention to the two arguments that we have inside of our parameters list. We have name and an 18, which you should be able to see. Age, right here in front of this 18. These parameters that you see here map to the parameter list that we have in our primary constructor. Whatever our primary constructor lists out in its parameter list, when you're creating secondary constructors, you must pass arguments to match the parameters inside of the primary constructor. Now, the thing about secondary constructors is that they're not very widely used. In fact, the general consensus seems to be that these are more of a hassle to use than an asset. But I figure I'd just go over this briefly anyway. Our second way of initializing variables inside of our classes is what's known as init blocks. Init blocks are just code blocks that are used to initialize code, as the name implies. You can have 0 or many, and they are also executed in order from top to bottom. Now, all of these are executed under the same condition, and that condition is when we're instantiating an object of a class. So with that being said, you may be wondering, well, is there a particular order to when these things happen? And the answer to that would be yes, there is. It goes primary constructor first, followed by any initialization blocks that we have, and finally any secondary constructors that we have. Secondary constructors with an S because you can have multiple secondary constructors. Like so. On line 25, I created a secondary constructor with an empty parameter list. Once again, constructor, our parentheses, colon, this keyword, followed by another parameters list. Now you'll note that there's a difference between line 25 and line 20, that this had the arguments passed in name and the literal 18. This name comes from the name that was being passed into our constructor. What we're saying is, whatever name that's passed in, pass that into the primary constructor as well. On line 25, since we're not passing in any arguments, we need to give some default arguments to go into our primary constructor. Now, we need to make use of these classes and objects that we've been discussing thus far. On the left side of your screen, I have in a function called main. On line 5 in that function, I have created a variable person A. Person A is being assigned an object of the person class. In order to create our objects, the syntax is very simple. We have the name of our class, as we can see here on line 4 on the right side of the screen. And we're going to pass in the arguments needed for the constructor. Now on line 4, I have a comment, creating an object using the primary constructor. We have our class name person, and we're going to pass in some arguments. We're going to pass in the string Virgil Sparta, which represents the name, and 35, which represents the age. That's going to create an object of the class person, and then we're going to assign that to our variable person A. It is entirely possible, of course, to make use of all these things that we have inside of our classes. If we want to invoke a class member, if we want to reference a field inside of a class, all we do is we take our variable, which holds our object, followed by dot, and then whatever member we're trying to reference. On line 9, I'm simply printing out person ID. We have a string template, persona.id. This is going to reference the ID that we have on line 8 inside of our person class that you see on the right side of your screen. The output of that is going to be person ID colon some random number. I put some random number here because, once again, hash code just returns a random integer. It returns a hash code value for the object. To invoke a class method, we follow the same syntax. We have our variable, which contains our object, person A, dot, the name of the method that we're trying to call. And we make a function call the exact same way we've always done it. Function name, followed by parentheses, and any arguments that need to be passed in. Print info doesn't take in any arguments, so we just leave this blank. Inside of our print info function, we just print the name and the age inside of our object. Now, we also create on line 15 a person's B object, a person B variable, and we're going to assign it another person object, except this time we just pass in a name. What you see here matches up with our secondary constructor. So the end result is the same in that with person A and person B, we get an object of a person class that has whatever variables that we pass into it. Person B works the exact same as person A. Person B, I can call the print info function and it prints out the same output. Well, the same format of output. You may be wondering, when we're creating an object of a class, how does Kotlin know whether we're using the secondary constructor or the primary constructor? Well, in Kotlin, it makes it a little bit easier to see this because you see that your primary constructor, it has two parameters. It has a name, which is a string, and an age, which is an int. Our secondary constructor, however, just takes in a name. Now, for all intents and purposes, these are still two constructors. The question is, how does Kotlin know which one to call? Because we have the concept of function overloading. Function overloading is functions that have the same name, but different parameter lists. So for instance, see how on line 26 I have print info? Well, I can do something like this. You'll notice how thus far I have just function print info with an empty parameter list. Well, we're going to get an error because we have conflicting overloads. These are the same thing, even if they don't do the same thing. When we're speaking on overloading, they don't care about the contents of what these methods are doing. They just care about the signature. We fix this error by adding a parameter list to our print info function, the second print info function that we have. As you can see, I just added a parameter name of type string, and that fixes the error. Now, on your screen, on line 30, I have a print info function that takes in a name. And on line 34, I have a print info function which takes in a name and an age. You'll notice how each of these functions have the exact same name, just different parameter lists. This is what is called function overloading. Or, since we're inside of a class, method overloading. Now, if you pay close attention to the contents of these functions, you'll see on line 27, we use this dot name this dot age, as opposed to our print info function, which takes in just a name, we have string template name, not this dot name, like how we have with age. And in our print info function, line 35, we use string template just name, not this dot name, and age, not this dot age. Well, that is because this is a special keyword in just about every language that it exists in. In the context of Kotlin, this represents an instance of a class. When you're using this, it's representing the current instance of the class that is being called in. When you use this.name, what you're referring to is the name that is inside of our object. That is different from the name that we're using on lines 31 and 35, because inside of these subsequent print info functions, we're passing in a name. How we differentiate between the name that we're passing in and the name that is already inside of our class is through the keyword this. Your code will know that this.name is referring to, once again, the name that is inside this object, which we have declared here, as opposed to the name that is just inside of our function. This name here and this name here are in two different scopes, the same way as this age here on line 31, this dot age is a completely different scope from the age that's on line 35. The same concept applies here as well. The age that we're using on line 35 comes from the parameters list that we have for our print info function on line 34. On lines 21 through 30, I've printed out all the output that is generated from this code. On line 21, we'll run some initialization code here. That comes from our initialization block on lines 12 through 14. Remember, the order of initialization goes primary constructor, init blocks in order, and any secondary constructors that we have from top to bottom as well. On line 22, we'll do some more initialization code work here. This comes from our second initialization block. Next is on line 23, person ID, which is just some random number, which we can see is coming from line 9. When we call print line person ID, person a.id. On line 24, we have name, Virgil Sparta, comma, age 35. This is coming from line 12 when we call our print info function inside of person A. You can ignore this little comment that I have here. Ended up redoing some code and forgot to update the comments. Now to break things down further, we know that Virgil Sparta, which if we look inside of our print info function, note that this is the print info function with an empty parameters list. So that means we're going to call this one here, this print info function on line 26. This print info function here makes use of the this keyword to print out this.name and this.age. Remember, this just simply refers to an instance, the current instance that is of a class. And this current instance refers to an object that has Virgil Sparta as the name and 35 as the age. Hence, on line 24, name is Virgil Sparta, age is 35. On 25 and 26, we see a repeat. We'll run some initialization code here, which we know comes from our first initialization block. We'll do some more initialization code here, code work here, which comes from our second initialization block, followed by calling secondary constructor, which we can see here on line 21. in our persons class. Now next, we're going to print on line 28, we have name, Yusuke Urameshi, age 18. This comes from line 16 when we call person b.printinfo. Now, since person b was initialized with our secondary constructor, we know that we're going to pass in a name. So this .name is going to be Yusuke Urameshi. Yusuke Urameshi is going to be passed inside of this name here, inside of our secondary constructor, and that is going to get passed into our primary constructor. We have the default value 18, which is being passed into our primary constructor as well. So that is why you see the age 18 here on line 28. On line 29, we print name, Kurama, comma, age 18. This comes from line 17, person b.printinfo passing in the name Kurama. This method call maps to our method on line 30 inside of our persons class. Printinfo, name, print line, name that we pass in, and this .age. So that is why you see the age 18 right here on line 28. Sorry, on line 29, because we're printing out this .age, which for this object here, person B, still has the age 18. And finally, on line 30, name, Hiei, age 20, which comes from on line 18, person B print info, passing in Hiei and the age 20. That method call maps to our method on line 34, where we pass in a name and an age, and we print both of those things out to the screen. The next thing we'll be discussing will be abstract classes. To explain an abstract class, it's easier to start with how to declare one. To declare an abstract class, it's like creating a normal class, except we use the keyword abstract in front of class. As you can see on the screen here, on line 3, we have the declaration abstract, followed by the keyword class, followed by the class name. As you can see, we're creating an abstract class called character. Now, some differences between regular classes and abstract classes are that an abstract class cannot be created by itself. In order to make use of an abstract class, a subclass is going to be needed. A subclass is required to make use of any class members that we have inside of our abstract class. Subclasses is something that we'll cover very shortly. Now, when it comes to regular classes cannot contain abstract members, as opposed to an abstract class, which can contain abstract and concrete class members. Going back to our abstract class character, let's go over some of the things that are contained inside of it. On lines 4 through 8, we see class fields. On lines 4 and 5 specifically, you see a different type of variable declaration. We have on line 4, protected, abstract, var, HP of type int. Line 5, we have protected, abstract, var, SP, also of type int. This is how we declare abstract fields. On line 6, 7, and 8, we do something somewhat similar, except we use protected, open, var, attack of type int, and it equals 0. Now this keyword that we see on lines 6, 7, and 8, open, the open keyword simply allows a class or its members to be inherited. By default, regular classes like the person class that we went over previously, by default, they're known as final. A class that is final cannot be inherited. So in order for us to open up a class to allow it to be inheritable, we use the keyword open. Open can be used for classes, it can be used for class members as well. You'll notice that on lines 4 and 5, our fields that we have declared abstract don't have an initialization, as in we're not assigning anything to them, compared to our open class fields that have 0 being assigned to them by default. Now you may be wondering, well, what is the difference between abstract and open in the context of fields? There's a concept that I keep discussing that we're going to cover real soon. And that concept is making something inheritable, which comes from a concept in programming called inheritance. A little sneak peek of that is that when you're talking about abstract classes, you're typically talking about a parent class and a child class. Parent classes, aka base classes, aka superclasses. These classes, as their names allude to, supersede another type of class known as a child class, also known as a derived class, also known as a subclass. We stated before that you can't make use of abstract classes or even as members without the usage of a subclass. Once again, you may see subclass, you may see derived class, you may also see child class. They're all the same thing. They're just classes that extend an abstract class. For simplicity's sake, I'm going to stick to using parent and child classes because it makes things a lot easier to understand going forward. Any child class is going to extend an abstract class or a parent class. Any members that are declared abstract, it falls to the child class in order to give an implementation of them. As you can see on line 4 and 5, we have an abstract class member. On lines 12 and 13, you see that we have abstract methods. Note that on line 15, we have a concrete function called perform base attack. On line 22, we have another concrete function called perform skill attack. And we have an open function on line 29 called display stats. For our open class members, they all have an implementation. We see what the implementation of what this display stats function is, same as we see with our regular concrete functions. But we also have our abstract class members, which, as you can see, have no implementation. Once again, the implementation of these fall to any class that is going to extend this abstract class. Now, you may also notice that you see this keyword here, protected, a lot. This protected keyword is actually here 8 times. All of our class fields are protected. Our abstract functions are also protected. This protected keyword is what's known as a visibility modifier. Visibility modifiers define what can actually see the property that it is attached to. In Kotlin, we have 4 different visibility modifiers. The first visibility modifier that we'll go over is actually one that we have the most experience with and not even know it. And that visibility modifier is public. Public is the default modifier. As you can see on line 15, I've added the keyword public. But as you can see, it's also grayed out. That is because, once again, public is the default modifier. So whether we have that public there or not, every class member that we have is going to be public by default unless we say otherwise. Public simply means any user that makes use of our class can make use of those public fields, methods, classes, etc. The next visibility modifier that we'll discuss is the private modifier. Any class member marked private can't be used outside of that class. On line 11, you see that I've created a private variable called example variable, and I've assigned it the value a string. I'm an example of private. Now, recall our previous work with classes. In our persons class from before, you'll remember our print info function. As we've stated before, by default, all of these members that we have inside of this person class here are public. Remember how I was able to just simply call the print info function by just using whatever object that we had created? Well, if I were to declare those print info functions private, we wouldn't be able to use them. That print info function could only be used inside of this class, meaning that if we have all of these considered private, what that means by declaring all these members as private is that you wouldn't be able to make use of anything inside of this class. The next visibility modifier that we'll go over is one that we've already seen, and that is protected. Protected works very similar to the private visibility modifier, except there is one key difference between protected and private. Whereas with private, nothing outside of that class can make use of that member. Protected allows for any class that extends this class, this character class that we've created here. Anything marked protected can be freely used within that class. And finally, we have the internal visibility modifier, as we see here on line 11. Now, the internal modifier is a bit interesting. The internal modifier denotes some member that cannot be used outside of this module. To help make this make more sense, think of a module as a set of Kotlin resources compiled together. When you're using your build manager, Maven or Gradle or Ant, for whatever reason, because I'm pretty sure Ant is no longer supported. When you make use of these things to compile your code into one source so that you can just hand that off to somebody, you're typically compiling that down to a jar file in the case of Kotlin, Java, or you can compile it down to a war file, as in WAR, a .war file, .war. Whatever is inside of that packaging, that jar, that WAR file, that is considered a module. To help paint a better picture of this, imagine that you're creating a weather app. That app has two modules inside of it. So you have the overall project, which represents the final product. That final product needs two separate modules that are going to perform specific tasks. One of those modules is a REST API, and the other is an image manager. Module A is our REST API, and that REST API contains a series of endpoints that perform some functions, as opposed to Module B, which is our image manager, that's sole purpose is to just manage images, supplying whatever image is needed whenever we need it. Anything marked internal inside of that REST API module cannot be seen by the project that is importing that module, nor can it be seen by the image manager module. The same way, anything declared internal inside of that image manager module can't be seen by the parent module nor the REST API module. If you know that you're creating some module that is going to be used by something else and you want to keep some things internal to that module, as in whatever this field is, whatever this method is that's declared internal, it is only supposed to be used inside of this module. Nothing else can use it. Now for the moment that we've been waiting for. We've discussed the topic of inheritance briefly, but now we're going to go over it in full. In Kotlin, all classes have the superclass any. A superclass is simply a parent of a class, which is why they're often referred to as parent classes. Looking at it this way, any represents the root of a family tree, as in you have the root of that family tree, and from that root you have every other class that is in Kotlin. Every class that is built into Kotlin, so integer, string, character, float, so on and so forth. down to the classes that we create, like the person class that we created before. When we're talking about superclasses, they also go by the name base class, and they also go by the name parent class. Usually in the circles that I've been in, most people just refer to them as parent and child classes, because once again, when you think about a family tree, it makes all of this make more conceptual sense. If we have a superclass, we have a subclass. Subclasses, also known as derived classes, also known as child classes. Another thing that we've gone over before is the concept of method overloading. Method overloading is when we have methods that have the same name but different signatures. As we saw before with our print_info function here, we have the function name print_info, but we have a print_info with 0 parameters. We have a print_info with just a string parameter, and we have a print_info with both a string and an integer parameter. Another concept that becomes very important when we're talking about inheritance is the concept of polymorphism. Polymorphism is just simply the concept that you can access objects of different types through the same interface or the same abstract class. In its base, the definition of polymorphism is one thing can take on many different forms. So without further ado, how about we explain all this by making a bare bones RPG game. Now on the screen, on the left side, we have created another class, a regular concrete class called Mage. This class has a primary constructor with just one parameter, a name of type string, where we just put a blank in there. Now, one thing that we haven't seen before is this colon followed by character followed by parentheses. What this does is allows our Mage class to extend the abstract class that we have, character. So to help conceptualize this, if you're thinking about an RPG game, you have a character. That character can be any number of classes. It can be a warrior, it can be a thief, it can be a mage, it can be an archer, so on and so forth. If you're not much of a gaming nerd, think about a shape. Now, if I say, hey, pass me that shape, well, on a table where I pointed and said, hey, pass me that shape, there are 6 different shapes. You have a hexagon, a triangle, a square, an oval, a circle, so on and so forth. Well, if I say, pass me that shape, which shape am I talking about? Imagine this abstract class as being abstract class shape. This class Mage here, imagine that being class triangle. Abstract classes allow us to pass characteristics onto other classes. By the Mage class extending character, we know that a mage can be a character. The same way, I've created a warrior class that also extends character. We know that a warrior is a character. And approaching that from the opposite end, a character can be a warrior and can be a mage. In our Mage class, on lines 4 through 6, we see that we have some class fields. We have an HP field, an SP field, and a magic field. Now you also notice this keyword here, override. What this override keyword is saying is that whatever members that we've inherited from the parent class, which is character, we're going to override those. You see that we have an HP and an SP. Well, these things come from our character class. What we're saying is, since these two variables are abstract, well, now we're going to give an implementation for those fields. Remember when I stated earlier that anything declared abstract, we need to give an implementation for? Well, that's what we're doing here. On line 4 and 5 inside of our character class, we have HP and SP, which are abstract. On line 4 and 5 inside of our Mage class, we have HP equals 90 and SP equals 20. So now we've given the implementation for those two abstract fields. Now a rule is whenever a class is going to extend another class, anything that is declared abstract in that class that we extend must have some implementation provided. If I were to get rid of line 5, you see that our mage class now has an error. That error is class mage is not abstract and does not implement abstract base class member protected abstract var sp defined in character. That is what IntelliJ has. I'm going to shorten that up to make it make more sense for you. Basically, we're missing an implementation. We add sp back in there, and that error is now gone. On line 6, you see that we have override var magic equals 30. Now, this magic also comes from this magic field that we have inside of character. Remember, on line 7, inside of our character class, the field magic is open. Open just allows whatever it is attached to be inheritable. Also keep in mind that by default, unless you declare something as open, it is final. As you can see on line 10 here, inside of that character class, I added the final modifier to our variable base damage. You'll see that it's grayed out because this is redundant. Another difference between abstract and open is that when something is declared abstract, we must give an implementation. As opposed to open, well, open, we can assign things to variables that have the open modifier attached to them. The same way on line 29, we have open attached to our function display stats. What this means is that we can give a different implementation of this, and we actually do, on line 26 inside of our mage class. But on line 26, you also see that we have the override keyword, meaning we are overriding the display stats function that we get from the parent class. And this child class is going to have its own implementation. On lines 12 and 13 inside of our character class, you see that we have some abstract functions. On line 12, you have abstract function calculate base attack damage. On line 10 in our mage class, we have override function calculate base attack damage. What we're doing with lines 10 and 16 is that we're giving the implementation of those abstract methods that we inherited from our parent class. Putting them side by side, you see that the mage class and the warrior class have some different settings, and they even have their own fields. On line 8 inside of our mage class, you can see that we have another variable. That variable is a private variable that we call spell chain. That is because classes that extend another class, they can have their own class members that are unique to them. For instance, we have spell chain. Well, unless you're making a spellblade class, a warrior doesn't have a need for a spell chain variable, so it doesn't have one. A mage class, however, would make use of that. So mage has the variable spell chain. Some other differences that we can see is that calculate base attack damage inside of the mage class looks vastly different from the calculate base attack damage function that we have inside of our warrior class. In the mage class, the modifier that we use to calculate damage is magic divided by 10 times spell chain, compared to the modifier inside of our warrior class, which is speed divided by 10. Now, of course, what fun would all this be without some examples of how all this stuff works? Going back to our demo file in our main function, on line 15 and 16, we're going to start creating some characters. On line 15, I've created a mage character. Remember, our mage character has a primary constructor that takes in a name. By default, that is going to be a blank character, but for the sake of our mage character, we're going to give that character a name. And that name is Kefka Palazzo. Never knew Kefka had a last name until I started making this video. On line 16, you see that I've created another variable called warrior char, which is going to house a warrior object similar to our mage class. It has a primary constructor with just one single parameter, and that is the string name. So on line 16, our warrior class, we're going to pass in the argument Squall Leonhardt. And with that, we have created a mage object and a warrior object. On line 20, using our mage character object, what we're going to do is we're going to call the display stats function. Inside, for our mage class, on line 27, we print the name that we see here, name Kefka Palazzo. And on line 28, we have super.displaystats. This super keyword represents the parent class. Remember, superclass is the same as a parent class. The super keyword .displaystats means we're going to call the displaystats function inside of our superclass. Inside of our superclass, we print HP, attack, magic, and speed. So as we see, we've already printed the name, so now we must print those other stats as well. We print the HP, which for our mage character is 90. We print the attack stat, which is 0. By default, attack is 0. The magic stat, which is 30, as we can see here on line 6 in our mage class. And the speed stat is 0. Once again, because 0 is the default speed stat. On line 26 and 27, we make use of two other functions. 26, we call perform base attack, which we see is defined here inside of our character class. In our character class, on line 15, we have perform base attack, which returns an integer. In that base attack function, it's just simply damage. The damage variable that we create is equal to calculate base attack damage. Now, we know that we can't be referring to the abstract class calculate base attack damage because, once again, there's nothing here to reference. So what we end up doing is we are going to call the base attack damage from the class that is being used currently, which is our mage class. The same thing is happening also when we call our perform skill attack. Perform skill attack just simply calls the calculate skill damage function inside of our mage class since we're using a mage object. We calculate that damage and we print dealt damage, which we can see here on the screen. On line 26, we dealt 136 damage. On line 27, we dealt 272 damage. All of this applies to our warrior class as well. Print stats simply prints the name that is inside of our warrior class object, followed by printing out the stats. HP is 110, attack is 20, speed is 10, magic is 0. We call perform base attack and perform skill attack, which prints out the damage that has been dealt. But remember when I brought up the concept of polymorphism? Well, we're going to see an example of that right now. On line 39, I have a variable evil mage, and it is of type character. Now, remember, abstract classes cannot be instantiated. We cannot create objects of abstract classes. What we can do, however, is take any class that extends our abstract class and assign it to a variable that is of that abstract class type. So you see here, we have evil mage, which is of type character, and we're assigning it a mage object with the name Magus. Now we know that mage extends character. You can also change this to warrior and it'll be just fine. The same way if we created a thief class and extended it from character, it would also work. You can even do something like this. As you can see on line 40, our evil mage of the character type, we're going to assign a Spellblade class that I just created. We create a new object of the class Spellblade, and we're going to pass in the name Mysterious. Inside of our Spellblade class, you see that we have class Spellblade, which takes in a string as its primary constructor, which is just character name, colon, mage, and that character name that we pass into Spellblade, we're going to pass into mage. You may be wondering, well, the Spellblade class extends the mage class, so what does a Spellblade class go inside of the evil mage, inside of the evil mage object, which is of type character? Think of all this inheritance stuff as looking at a family tree. We have the parent class character, which let's just assume that this is our root class. So we have character, which forms the root of our family tree. That character class has two children. It has mage and it has warrior. Mage also has a child as well, which is called Spellblade. Spellblade is a mage. Mage is a character, therefore Spellblade is also a character. Now, there are going to be some RPG purists that'll say that, well, a Spellblade is actually a combination of mage and warrior. So couldn't it also extend the warrior class as well? In terms of Kotlin, no, it cannot. We know that a Spellblade is both a mage and a warrior, but in terms of Kotlin, you can only extend one superclass at a time. There's one other class type that I also want to go over before we move on, and that is what is known as a data class. To keep it short and sweet, a data class is simply a lightweight class used primarily to hold data. Unlike regular classes, a data class must have a primary constructor with at least one parameter, which, as we can see here, we have 3. We have an amount, we have a description, and we have a date. Another thing to note is that unlike regular classes, a data class cannot be extended by another class, as all data classes are final. Under no circumstances can a data class be extended. So me adding this open modifier, we get an error. Modifier open is incompatible with data. Data classes also cannot be declared abstract, sealed, or inner. We add inner, we get an error. We add sealed, we get an error. We're going to make use of data classes in the final project that we're going to go over. But for now, let's go over our next topic. Our next topic of discussion will be interfaces. An interface is a collection of abstract methods and properties that define a contract for classes that choose to implement them. What that means is that any class that decides to implement this interface that we have here, it must give an implementation for any abstract methods and any abstract fields that this interface has. To create an interface, we start with the keyword interface, followed by an interface name. Some things to note about interfaces is that everything inside of an interface is public, meaning it can't be private, protected, or internal. As you can see on line 8, interfaces can also have concrete methods. Interfaces, however, cannot contain concrete fields. So with that, whether it is a field or a method, unless an implementation has been given for a method, then it is assumed to be abstract. So, adding the keyword abstract to line 4, which has our variable test, and to our save transaction function is redundant. Abstract classes and interfaces are very similar, but there is a key difference between them. And that difference is classes can implement multiple interfaces, but can only extend one abstract class. On your screen here, I have two classes. I have a Mongo transaction repository class, and I have a caching transaction repository class. Both of these classes implement the transaction repository interface that we see on the left side of your screen. You'll notice that the syntax is pretty much the same as when we were extending our abstract classes. We have our concrete class name, transaction repository, which is our interface. However, there is one thing that you'll notice is that the parentheses that were present when we extended our abstract classes is not here. To showcase this side by side, we have our mage class, character followed by parentheses. This parentheses is used to denote that we're going to call the primary constructor for our character class. Abstract classes can have constructors. So to add more to our previous point, recall that abstract classes can't be instantiated by themselves. They require their subclasses to do it for them. So abstract classes can have constructors, they just can't make use of them themselves. Over here on the right side, we have our Mongo transaction repository, transaction repository, and we don't see any curly brackets here because interfaces are not classes. So there is no primary constructor or secondary constructors. And that's pretty much all there is to interfaces. So without further ado, we can finally go into the project for this video. To close out our video, we are going to go over this app that I have given the name Ledgerly. Ledgerly is a simple expense tracking application, as you can see here. Some things about this app is that what we're going to do is we're going to start off with a command line tool. This application will read a comma-separated value file, or CSV. That CSV has a list of transactions. Once this file is read in, we give the user a list of options. In actuality, I have them up on screen now. So option 1 is to view transactions. This is a function that allows us to view every transaction that is inside of that file. Option 2, view transaction by ID, meaning we can take a transaction's particular ID and then view information specific to that transaction. Option 3 is adding a transaction. 4, remove. 5, update. 6, the ability to save that ledger. And 7 is a quit option. Now, since this is strictly a Kotlin video, meaning we're just learning about Kotlin, we're not going to be incorporating an actual database. So we're not going to be using MySQL, Mongo, Dynamo. Those are for another video. On your screen here, you can see that I have an interface, a Ledgerly transaction repo. Now this repo has all of those functions that we just went over. We have our function for add, removal, and updating a transaction, getting a specific transaction, listing all transactions, and saving a ledger to a file. You also see, just keep in mind that this is an interface. What you also see is local Ledgerly transaction repo. What we have here is a particular design pattern. This design pattern is the strategy pattern. We have a Ledgerly transaction repo interface, which is then implemented by another repo class. That class is going to give all the specifics needed for what it needs to do. That class is then going to define, per the contract, how we're going to add that transaction, how we're going to remove a transaction, so on and so forth. Now, since this is only dealing with local, what we're going to do is store all of this in memory, which we can see here by our in-memory ledger property, which is just a simple hash map with the key string and a transaction. Now this transaction object is represented by a data class. That data class has a primary constructor, which is just the amount for that transaction. Inside, we have this private var called character pool, which is essentially just the entire alphabet in both upper and lowercase, in addition to the digits 0 through 9. As we can see here, this is defining all the letters between A and Z that are lowercase, plus all the values between A uppercase and Z lowercase, and finally, all the characters between 0 and 9. Now, we want to create a unique ID. So as we can see here, we have a range from 1 to 5, meaning we're going to create an ID that is 5 characters long. .map is another way of looping through a collection, and then we perform some specific task. What we're doing here is we're going to take a random integer from 0 to character pool size. The size of this would be the letters of the alphabet times 2 plus 10. So 26 times 2 is 52 plus 10, which is 62. So from 0 to 62. Going back to our data class, we also have some other properties, such as a description and a transaction date. Now by default, description is just an empty character, and transaction date is a nullable local date, which we have set to null. We can also do something like this, where local date will just be the time of whenever we create this object. I also have a print transaction function that we can call to just print out whatever that transaction is, its ID, the amount, the description, the date, and a simple new line. And then what you'll see here is in the string template, we have a string %.2f. All this is saying is this string dot format passing an amount. This is what's going to allow us to turn our doubles like 47.0, which would be in human terms when we're talking about currency, would be $47. But that extra 0 to a computer means nothing and is useless to it. So $47 to us is 47.00, but to the computer is 47.0. We drop the extra 0. What this does here is it allows us to put it in a format that is human readable. Well, what makes more sense to a human. Now we also have a copy function. This function is used to simply, as the name suggests, copy a transaction. Now this function is going to be very important coming up. So pause here to get a good look at exactly what it's doing and just keep this in mind. Now that we've explained the transactions that we're going to be working with, we can go back to our discussion on this repo class that we have here. Now, recall that earlier in the video, I referred to the possibility of us having different types of repositories. This, as we see here, is a local repository. It can honestly be renamed to be in-memory Ledgerly transaction repo, but local is shorter, so I went with that. Now, implementing this Ledgerly transaction repo interface, we can do the same thing for a Dynamo repo. We can do the same thing for a MySQL database or repo. We can do the same thing for a Mongo repo. Remember that interfaces essentially enforce a contract on a class. That contract says that you have to implement these functions. So for the sake of simplicity, on lines 7 and 8, we have a default out file, which is just called ledgerly.csv, and a default directory. Here on line 9, we have another private variable called outFile, which is set to equal if out, which is a parameter in our primary constructor. If that is blank, then we're going to use a default outFile, meaning if you wanted to change the name of the file, you're free to do so. Any class that is going to implement the interface Ledgerly transaction repo, they're contractually obligated to give some definition for these methods over here on the left side of the screen. Well, this is how the local Ledgerly transaction repo handles that. We've even added some comments here to describe what each of these methods do. Add transaction adds a transaction to our repository. It takes in a parameter, tx, short for transaction, which is just simply the transaction to be added to our repo. Now, in the context of our local repo, what it's simply going to do is in-memory ledger, the key transaction ID is going to equal our transaction. Moving on to our remove transaction function. This function has a parameter transaction ID, which is the same thing that we see up here. On line 23, transaction.id. That's what we're going to be passing in here. In-memory ledger dot remove that transaction ID. Dot remove is just simply a function for hash maps, which just simply removes the mapping for the specified key from this map in memory ledger if it exists. Our next method, update transaction. This method looks for an existing transaction based on the ID in the param transaction. If a match is found, we'll update the existing data. If a match isn't found, an exception gets thrown. Now, there are two ways to handle this. I opted for, if the transaction doesn't exist, then we don't do anything with it, meaning we're not going to add the transaction if it doesn't already exist. To add a transaction, if it doesn't exist, would be what's known as upserting. To upsert would be, if that transaction doesn't exist, then we just simply add it. Which one you would do really depends on the parameters of the application that you're designing. But once again, to keep things simple, I just opted to, if there's no match, then just throw an exception. What we're going to return is a transaction update results object. Transaction update results is just simply another data class that we've created, where it has a previous transaction and a current transaction. This previous transaction denotes the transaction before it got updated. The current transaction denotes what it is now. And this class also has a print changes function, which just compares the previous data with the current data and prints it if there's any differences. So if we didn't change amount, we wouldn't print anything. If we change the description, however, then we would print this.previous_transaction.description arrow. This is just a style thing. This arrow here that we have highlighted doesn't mean anything. It's just me saying the description changed from whatever it was previous to whatever it is currently. And we also do the same thing with date. Get transaction returns the transaction matching the provided transaction ID. If not found, an exception gets thrown. So, similar to our remove transaction function, we pass in a transaction ID and we just simply look for it inside of the in-memory ledger. So, val transaction equals in-memory ledger at transaction ID. What you see here that I have highlighted, this question mark colon, is what's known as an Elvis operator. To put it super simple, if this isn't null, because if there is no transaction for this ID, then we're going to get null. This Elvis operator, I'm not sure why they call it that. It is a binary operator that looks at our first operand, which is this in-memory ledger at index transaction ID. If the result of this is null, then we're going to do what is on the right side of this operator, which is throw a transaction not found exception. If it isn't null, then we just simply assign the value for this key inside of our transaction, which is just a transaction. Finally, on line 65, we're going to return a copy of that transaction. Now, the reason we return a copy instead of just sending this transaction is listed here. We need to return a copy of the found transaction, otherwise we're going to pass a reference to the calling function, which allows for direct editing of a transaction. In programming, you have the concept of pass by value and pass by reference. Now, in the context of this function here, pass by reference. Pass by reference means we're passing a reference to this object in memory, meaning in memory, the address for whatever it is that we're returning. That means that whatever calls this function is going to get a reference to this transaction, meaning if we were to edit this, we'd be editing that direct object in memory. Now you'll see why this is a problem shortly. For now, let's add our .copy back and go over why this copy is needed. Inside of our Ledgerly application Kotlin file, we have two functions. We have remove transaction and update transaction. The key method that we have here is this get transaction from user, which just takes in a simple prompt. Now to summarize this function takes in input from the user. That user input is going to be a transaction ID. Once we get that transaction ID, we're then going to search for that transaction ID. This our Ledgerly repo object get transaction, passing in that user input, is calling this function here on the right. Now, remember what I was mentioning about pass by reference. Rather than sending the direct transaction that's in our memory ledger, rather than sending that back, what we're going to send back is a copy. Going back to update transaction, pretend that we're sending back our in-memory ledger transaction for whatever the ID that the user inputs. So we've gotten that transaction. Now we're going to start to update it. The user enters a transaction amount. We do some stuff to make sure that the user doesn't fat finger something, input something incorrectly. The user enters a description. They also have the option of just pressing enter. For each of these options, they have the option of just pressing enter to use whatever the current thing is, meaning nothing is updated. Do the same thing for our transaction date. Now, down here, we're going to call Ledgerly repo update transaction with this new transaction that we've created from the data that the user has supplied. This transaction here is the updated transaction. Line 45, value previous transaction, is going to get the transaction that is at this key here, which is the ID of the transaction that we pass in. Now, remember, from our understanding, we haven't updated anything in our ledger yet. If you've noticed, we don't edit the ID anywhere. So the ID should still be the same. It's just that the amount, description, and the date can be different. So, for all intents and purposes, let's say we have the transaction with the ID 123. In-memory ledger's transaction at 123 should not have changed until we hit line 47, where we assign it the new transaction that we have created. We're going to return a transaction update result, passing in a previous transaction and the transaction that we've passed in. But remember, the scenario that we're currently going through, we didn't pass in a copy. we pass directly what is in memory ledger at the ID that we specified. In this instance, 123. Now, what do you think previous transaction and transaction are going to be? Well, since we passed in the actual in-memory ledger transaction, previous transaction and current transaction are going to be the exact same thing, because what we've done here is, well, actually, before we even got here, get transaction from user, which just ultimately calls get transaction. This transaction on line 111 is the actual transaction that is in our ledger already. So when we do transaction.amount equals whatever the user inputs, same thing with description, and the same thing with the date, we were already editing or updating that transaction. So this is why we pass a copy when this method is called, because we don't want the user to be able to directly edit it unless it's within one of our methods here: update, remove, addition. Hopefully the explanation for all that was very clear. The key takeaway is understanding what pass by reference is. When you're passing around a reference to some objects, you're passing a means of directly editing that object, which I would say most of the time is perfectly fine, because that might be exactly what you want to do. But with how I have things set up here, being able to edit that in-memory object is not what we want to do. We want to have a very controlled way of being able to edit things, so we don't have weird issues where you might spend roughly about 30 minutes trying to figure out why a transaction is showing that there have been no changes. On line 68, we have a simple list transaction function, which is just going to, in some format, print out all of the transactions that are in our in-memory ledger. We also have here read ledgerly file and save ledger to file. In order to operate on a file, both of them call this get ledger file. Get ledger just checks to see if our default directory exists, and if it doesn't, it makes that directory. If it does, we just print found directory, that directory to the screen. It checks for the actual file that we're going to be using, our out file, which should be ledgerly.csv. If that file doesn't exist, then we simply create a new one. And if it does exist, print we found the file. So we get that file, and read ledger, of course, reads it using a buffered reader. And lastly, we have our save ledger to file function. After we get our file, we're going to create a writer, a buffered writer. On line 104, we have in memory ledger for each with our Lambda here. We're going to take that writer that we created on line 103 and append a line to that file in the following format, which is just what you see here on the left. On line 107, we call our close method here that is inside of our buffered writer. When dealing with any type of writer, always remember to close them when you're done. And that about covers the major nuts and bolts of our application. The only other thing would be these two exceptions that I've created. I've created a user exit exception and a transaction not found exception, which both extend exception. Exception is the parent of all exceptions that you have in any language, really. The reason I've created these two classes, these two exception classes, is just simply so that it makes things a little bit easier to understand when looking at the code, because a user exit exception is not something that's terrible. It just is used to denote that the user wanted to exit something. We have exits all throughout this application. We just throw this user exit exception to denote that, hey, the user wants to quit. and thus we quit and go do something else. Same thing with the transaction not found exception. If the transaction isn't found, it's just not found. It's not some big deal. It's just we throw this exception and then we do something or don't and continue moving. One more major thing is throughout this discussion here, I've mentioned the pulling in information from the user. The user types in some information. That is handled by our scanner class that is being utilized on line 12 here. Scanner constructs a new scanner. Scanner, by name, scans something. That something is what we pass here. What we're passing is system.in, which is basically just the input that the user types in. So we're scanning the input that's given from the user via your keyboard. You'll see this input reader throughout the application, for instance, on line 21. Now, the next line function that we call inside of our scanner pulls data from the user as a string. Since our option is supposed to be an integer, we just simply call toInt, which is a built-in function in Kotlin. On line 23, we have a when expression. When option is equal to 1, we're going to call view transaction. When it's 2, view transaction by ID. 3 is add transaction. 4 is remove transaction. 5 is update transaction. 6 is save ledger. And 7 is inprog is equal to true, which is going to break our loop. Line 34, we thank the user for using the application, and then we just end the process, which is just kill the program. As you can see, a lot of the different things that we've gone over the course of this video have been utilized inside of the creation of this application. The exceptions that I was talking about earlier, you can see right here. We have a try catch block. We have some prompt. Enter the ID of the transaction that you're searching for, or type quit to go back. We explained this a while back, but get transaction from user takes in this prompt here, which is used to tell our user, hey, you can provide input now. If the user types quit, we check for that. And if they type quit, we just simply go back to our loop. So without further ado, let's actually see how this application works. We have from our main function, we start by printing, starting the Ledgerly expense tracking application. We found our data directory. We also found the ledgerly.csv file. So now we come to our greeting here. Welcome to the Ledgerly command tool. Enter an option below. So let's view all of our transactions thus far. Now, as you can see, all of our transactions have been printed on screen in the format that we specified earlier. We have ID, followed by amount, followed by the date, and the description. We have our ID, the amount in the format that we want it, $40.20, our date, and a description. Now let us copy one of our IDs. So I want to view a particular transaction. So I give option 2. Enter the ID of the transaction you're searching for, or type quit to go back. So I'm going to give the ID that I just copied. And as you can see, ID, amount, description, and date, the same as what we have up here. I want to view another transaction, but then I changed my mind. So I type quit. We just simply go back to our options. So now I want to add a transaction. We enter a transaction amount. Let's just say $247.12. Description, transaction date in the format year, month, day. Let's give today's date. We see adding. We created a new ID. We have an amount, $247.12. The description is hello viewer. And the date is April 4th, 2024. Now, I want to clear some of that test data that we have from before. So I'm going to grab one of those IDs, and we're going to remove that. Hit enter. This is the transaction data right here. Let's do a search to see if we still have that transaction. We do not. Transaction not found. Okay, so I can type quit to go back. I'm going to grab another test transaction ID, and I'm going to update it so it is actually something useful. As we see on the screen here, enter transaction amount, press enter for the current, which is just $40. Forgot to add that formatting here, but we're going to change it anyway. $1,000.57. A description. We're updating this transaction. Transaction date. We're just going to use the same transaction date. So I just type enter. We see updating. 40 became $1,000.57. Test 5, which was our description, became we're updating this transaction, and there's been no change to the transaction date, so we don't print anything. If I were to just quit the program right now, none of the changes that we've made would persist. So we're going to save them now. Fount directory data, fount file ledgerly.csv, writing 10 rows, and we're done. We can quit the application now. Thank you for using Ledgerly. C space cowboy or cowgirl. And as we can see over here, ledgerly.csv has all of those changes that we just made. We have our added transaction. We have our updated transaction. And this is one from previous testing. So we've now reached the end of the video. Hopefully Kotlin makes a bit more sense to you. Sorry for the delay in getting this video out there. There have been a lot of things that I have been piling on myself, and it's been a struggle juggling all these things. As stated before, I hope you found this video useful. Be sure to like, comment, and subscribe, and I'll see you guys in the next one. Take care.